All right, so today what we're going to do is we're going to begin our look at what's called the Cartesian Plane, guys. This is also known as the rectangular coordinate system. They have two different names. You can call it whatever you like. Don't care. I usually call it the Cartesian Plane. It's called Cartesian because it's named after a French mathematician, René Descartes. So that's where that funny word comes from, Cartesian. But we're going to talk about some of the basic ideas about the Cartesian plane, how it's constructed, what makes it up, and how to use it. Okay? Now, this section is a continuation of the section we did on linear rules. Okay? Remember when we looked at linear rules back in the day, we had some number, right? It is just 1, 2, 3, 4, 5. And then the pattern would tell us what number we got. So we could have 3, 5, 7, whatever, right? 9, 11. And we did the rule finding the common difference. What's the common difference between these?
The number between each.
Yeah, the number between them also, which in this case the number is 2, right? And then we knew that was our multiplier. So we knew we had 2n. So we called that number t, right? Now, this is just a review. If you want to write it down, you can. And then many times, though, because then you have to see if it'll work, so you just plug in the first number. If you did 2 times 1, that gives us t equals 2. Is that true for our number there? No. So we had to have something to make it bigger. What in this case? Sorry, that's okay.
What is t?
T is just the number you get, the number you get. It's just a name for the number. No, so it doesn't really stand for anything. So in this case, in order to turn that 2 into a 3, I need to add a what? Plus 1. So then that gives me the pattern 2n plus 1. Remember when we did those? Yeah. Now, we can test it. Let's test it with 9. What is our n for 9? 4. So t should equal 2 times 4 plus 1. 2 times 4 is 8. Plus 1 is? So is it true? Yes, so we've got the right pattern. Remember doing that? Where we did the common differences, yeah? Okay? Mm-hmm. Well, we plugged a number in place of the n, right? So n only occurs when we have our pattern, but then we used n of 4, and so we put the 4 in place of the n. Substituted. Remember when we substituted? Just substitute just means replace it with a number in a bracket and then do the math. Okay? And we could have used any of these values, and it would give us the same true statement. Remember those? Okay? Well, what we're going to do today is we're going to look at how to draw a picture of this relationship. Right? And so first thing I want to talk about is that these relationships are linear, which means the pictures of these relationships will always be a straight line. That's where linear comes from. It means that it's a straight line. Okay? So when you're graphing these, not the things we're going to do today, but when we actually graph the rules, you're going to end up drawing straight lines. So if I graph it and I get a line that looks like this, am I happy? No, it should look like this or this, right? Okay? So just a straight line. So you can keep that in mind that when you're graphing linear and you don't get a straight line, then you probably have a mistake somewhere, right? Okay? And it's usually a sign error. Okay? So let's pause the recording for a moment. Here we go. Now this does not mean that you're not taking notes, right? I'm still going to write things down. You should write things down as well. So here we go. And I have no idea why the graphing tool is a jellyfish, but get used to him. He's never going away. Look, I like the sloth. So the Cartesian plane is named out again after René Descartes, who invented it. Anybody know that René did? Do you know the other René? Yeah. So this is René with one N though. So oh well, French guy. So what he was doing was he was lying in bed and watching a fly on the ceiling, and realizing that his life was really sad at the time. Realizing that he could show the directions and the movement of the fly mathematically. right? It would go like 2 steps that way and 1 step that way and 3 steps that way, right? And that's where this comes from. So it's pretty amazing, and now you are going to be able to use it to solve all kinds of problems and to be able to make a drawing of a mathematical equation, which is pretty cool, and doing lots of things and using a lot of problem-solving skills by doing this, okay? All right, here we go. So what we're going to do is first look a little bit at the Cartesian plane. If you look at the Cartesian plane, what we have here is simply 2 number lines, okay? So it's 2 number lines, okay? Right? Question? It's the same. It's the same. That at this level we just don't focus a lot on the negatives. Yeah, I'm gonna draw you the proper one in a minute so you can see it. All right, it's 2 number lines, and they cross where they both equal 0. Okay, so they both equal 0. That's their crossing point. And that crossing point is a critical value for you. It has a special name, and you need to know it. It's called the origin. Now, if you think about the origin, that's where everything originates, or in other words, that's where everything begins. Right? So everything begins at the, what's it called again? The origin. Right? And the origin is the place where both number lines equal what number? 0. All right? Okay. So, that's right there in this particular drawing. It's where they both cross. You'll notice that one number line is going horizontally. Horizontal means flat, right? Okay. Okay. So, well, yep, this one's horizontal, and that one is called the x-axis. Axis is just the name for the number lines, okay? So the x-axis. The x-axis goes from left to the right, not over. That's one of my pet peeves. That's why we did that little exercise. There's no such thing as over. You either go left or you go what? To the right. Now in this one, they only give you numbers on the right-hand side of 0, which means they're all what sign? If they're on the right of 0, positives, right? But if you were to go to the left of 0, that would be fine. The numbers would simply be what? Negative, okay? And that's what tells you the direction. If the number is negative, you're going to go to the what? Left, negative, below 0. If the number is positive, you're going to go to the right. Make sense? To the right of 0 are the positives, to the left of 0 is the negatives. So the sign tells you which direction you're going to be moving in. Okay? Yes?
Why can't they write 0 on the
Because you can just assume it's there. Right? Because it gets kind of cluttery if you write 0, 0 there, because there's no space for it like there are the other numbers. Okay?
0 have like a little line through it?
Nah. It's all good.
Because in algebra it could be an line.
Yeah. I think the reason why it doesn't have 0 is because it's supposed to be a perpendicular line, and if it's 0 there, you can't see it.
Yeah, right, exactly. So if you put the zeros there, you'd have to put them off to the side. You can't really put them where they belong, right? And so it doesn't make any, so it just looks like clutter. So it's just always assumed. And that's why we make such a big deal of it, that is the point 0, 0. Okay? All right. Good questions, guys. Now the y-axis is this one that's going up or down. What's up or down called? Not horizontal, but vertical, right? Okay? So keep these terms in mind. These are very important terms. So, horizontal.
Like the horizon.
Like the horizon. And what? Vertical. Like the verticality. I don't know. I'm just messing with her. All right. So,
Who?
anybody? Nobody in particular? I would never mess with a student.
You just said that you were messing with somebody.
I'm just seeing if you're paying attention. Okay, so vertical means what? Up and down. Horizontal means across, left and right. Okay? So the y-axis will tell you to go either up or what? Down. And what sign do you think it is if it's going up? You're above 0, so that's a positive. There you go. And down would be a what? Negative. That one most students don't have any problem with. It's this one that bugs students because they'll always say, oh, go over 5. Does over tell me anything? Nope. I don't know whether you mean right or left, right? So, but what if I say right 5? Does that tell you something?
Like battleships.
Yeah, so you're going to the right 5. It's positive.
I
You're
just
like
always think
battleships.
of Cartesian planes
Okay.
like battleships, because any number you say. It's like,
There you go. So if we did a full Cartesian plane, it would look like this. Now notice this one kind of doesn't do the negatives because the focus at this level is not sign numbers, right? The focus at this level is going to be on the positives, and that's why. But you guys, I'm going to drag you a little further than that because I think you can deal with it. Okay? So if we have 1, 2, 3 going this way, on this side it would just be what? The negatives, yeah. If we have 1, 2, 3 going up, just down would be what? -1, -2, -3, right? So that's what the full Cartesian plane looks like. Most applications, however, will only use this square here, which is what they've drawn here. Now let's think about why that would be. If you're doing an application, for example, the number of students in a particular class, the number of students can never be negative, can it?
Yes.
Do you see? Well, show me that negative kid. Well, never mind. I know lots of negative kids. But you know what I mean. There can't be a negative kid. That you still exist. You're still positive even if you're not in the room, right? Now, so, or if you're talking about time, is time ever negative? If you go back in time, you let me know because there's a sweater I lost I want back. All right? Then, if you're talking about money, can money ever be negative?
yes, you can
can't.
acquire debt.
If you can't have, yes, but you can't physically have less than no money in your hand, right?
10%
Okay.
of the money is physically.
So,
But you can look like a debt in the bank.
A very little percent of
that's
money
debt.
actually
That's not the same
exists.
thing.
The
Okay?
rest of money is debt. There's no actual money.
So, don't be so literal on me, kids. Or be more literal. Don't worry about we're talking about physical things here. All right? Talking about things we can measure. So most of the things that we can measure are positive. Does that make sense? And that's why for most applications, you're only going to use that one square. Now, can you have negative numbers in mathematics? Absolutely. So when you move forward in your mathematics, you're going to have lots of negative numbers. Okay? All right. What if I told you that I didn't want to go right or left any? Where would that be? What's it called? The origin. Nowhere, yeah. No, but nowhere has a name now. It's called the origin, right? Okay. All right. We good? So ready? All right. Here we go. So from that, you should have gotten that the x value is what? Horizontal, which tells you either what? Left or right. Excellent. The y value is vertical. And yes, you need to know horizontal and vertical and which one's which. Okay, it's really important here. A vertical, which tells you you're going either what? Up or down. Okay? Up if it's what sign? Okay? Down if it's what sign?
Negative.
Right if it's what sign?
Positive.
Left if it's what sign?
Negative.
Okay? So this time we're going to play our little game again. Okay? We've talked about most of it already. So the Cartesian plane, again, is just two number lines that cross where they both equal what number? 0. And that point is called the origin. Excellent. Okay? The horizontal one is called the what? X-axis. The vertical one is called the what? y-axis. Excellent, guys. Good job. Okay, shh, guys. And again, every piece of every space on the Cartesian plane has a specific pair of values. So our next thing that we want to talk about are what are called ordered pairs. These are also known as coordinates. Okay? So, either way you want to think of it. Many times people are more comfortable with the word with the term ordered pairs, because if they're ordered, that means they are always in what? Order, right? And if they're pairs, there are always how many of them? Two. Okay? And here's what they look like. You have X, comma, Y. Okay? So this is what an ordered pair looks like in its general form. Now remember, we've used that phrase before. General form means we're using letters instead of numbers, right? We're just making a sentence, a rule kind of thing. So it's always X, comma, what? Y. And your X values tell you how far to go, either right or what? Left. And your Y value tells you to either go what? Up or down. Now, if I have an X and a Y, that means I'm going to go right or, and then I'm going to go up or down. Okay? Guys, focus with me for a second because this is really important. If I told you to go down the hall 20 feet or whatever, 20 meters, I forgot y'all can't deal with feet, 20 meters, and then I told you to go left 30 meters, would you come back to where you started to go before you went left? No, right? You'd go one direction, then you'd stop there, and then you would go, then you would go the other direction from that point, right? You don't go, come back, and then start again, yeah? And that is a really hard problem for some students to get over. When you're talking about, working with the Cartesian plane, you're going to go so far over to the right or left, because which value always comes first? The first value in your order pair, is either left. So that's either right or left. Oops. Don't spell right with an O, do you? Okay. Either right or left. And that's when you to do first. And then second, from that point, from there, go either up or what? Down. Or down. And if you can do that, and you can count, you can graph. How lucky are you? Can you count? Most days? Okay. So, most days you can count. All right, that's good. Me too. You're always going to go which one first? Right or left? And which one second? Up or down, depending on the signs. And again, we're working mainly in that positive section, so it's going to be right and what? Up, generally. Okay, so what I want to do is, I want to look at this point, this value, and we're going to see that it has an X value and a Y value. Yes? There will be always a number. It has to be. Even if it's 0? Yes, they have to write it. Yeah, they have to write it. Okay, so if you look at this. So this blue dot, guys, come on. This blue dot is, hold on just a moment. This blue dot is a point on the graph. Okay? So this is a coordinate. Yes?
I was just wondering, what comes first when we're multiplying the y side or the x?
Well, we're not ever going to multiply these things. Yeah. All right. So that is a point. It has an X value and it has a Y value. Which one always comes first? X. And notice that they're always enclosed in a bracket. That's how you know that it's an ordered pair and not just a list of random numbers. If I told you 3, 4, that could be 3, then a 4. It can be anything. But in order to indicate that it's an ordered pair, I have to enclose it in a bracket, right? So that's what they look like, and they'll always be in that format. Okay?
Do people remember that X comes first by because in the alphabet?
Yes, it's alphabetical order, but if you had specific names for them, they may not be. For example, if this was time and this is distance,
It'll always be T then D.
T then D, right. So you can't always assume that it's going to be in alphabetical order. Now, if they're just any random letters, then they will always be given in alphabetical order. Okay? All right, here we go. So I want you to find the X and the Y value for this. Guys, ready? All right. So beginning at the origin, what I'm going to do is I'm going to count to there. But remember, my X and Y tells me how far to go right or left. So I can't just count diagonally. So first, I've got to get to the blue line by going in which direction? Right. To the right, how many units? How many units? 11 units. So my X value is 11. But I'm still not at my... Guys, I'm still not at my point yet. From that 11, I need to go where? Up. How many units? 15. So my Y value is 15. So the value, the coordinates for this point are 11, 15. So to the right first, and then what? Up. Until you get to the blue dot. And all you have to do is find the values that correspond. Okay? Yes?
So how do you know that the 11 is from the x-axis and from the y-axis?
Because we went to the right 11, and the X value always comes first. Right? So you're always going to go right or left first. So that's always going to be for an X value. And then you'll go up and down. Okay? So, all right. So we're going to look at several of those. That's our big focus today, is to do exactly that. We're going to be looking at values from a point. Okay? All right. Now again, the point where two axes is cross. Axes is simply the plural for axis. That means both of them. They cross at what's called the what? Origin. And what do they both equal at the origin?
0.
So the ordered pair for the origin then is 0, 0. Because that means go right none and what? Up none. Right none, left none, up none, down none. So 0, 0. So the coordinates for the origin are always what numbers?
0.
0, 0. Does that make sense? Go none. 0 means none. There we go. All right. So, the defining feature of a Cartesian plane. One number that curves to make a circle. Did we mention that anytime today? No. Two number lines placed at right angles to each other. Yes, because what does it mean when they're at right angles? That means they're to make a perfect corner. So 90 degrees. We've talked about 90-degree angles. So yes, an infinite grid with no numbers or directions given. No, they give numbers, right? Two numbers that are number lines that are parallel to each other. What does parallel mean, guys? Yeah, they never touch, right? They're all going in the same direction, the same distance apart. So what is it? First, second, or third?
2.
Number 2. Two numbers that are at right angles to each other. Okay? All right? So what I'd like to do is we're going to go through this exercise together. Now I'm going to give you some support, but I'm going to call on somebody to answer. So pay attention. I will be there for you. I'm not going to just dump you out on your own, but you're going to have to think about it a little bit and pay attention. All right? Where's my list for you guys? Let's stop the recording. So remember that you can have the same numbers in a different order, and you get two distinctly different points on your graph. Okay? Yeah, so be very careful about where the points are. Which one's your X and which one's your Y. Okay? All right. Okay. All right. And the name of it is always the ordered pair. X, comma, what? Always enclosed in a what? Bracket. There you go. Good. So here you go. If you're just putting points on the graph, then you should always name them with their ordered pair. Now, you wouldn't do that if you were drawing a line, because the ordered pairs aren't important. The name of the line is the important part. But anytime that you're plotting, guys, anytime that you're plotting points on a graph, you should name it with its ordered pair. All right? Are we happy with that?
Yeah.
Okay. So, and the name is simply the ordered pair that you get. Okay. We always write which one first?
The
X first, then the Y. Okay? What if I had different letters in the alphabet?
Always the U.
Alphabetical order, unless they stand for specific units, which you sometimes will have. Like time and distance, right? It's going to be different. Okay?
What about meters and like?
You don't have to worry about units on this. Yeah. If you have a specific area, a specific unit, it'll be given on your axes. You'll probably see some with that in just a moment. Okay? All right. X-axis always comes before the Y-axis. Okay? Yep. Yes.
So the units, do they always, on the X-axis and Y-axis, will they always go up on ones, or will they go up on twos, or like?
Excellent question. No, you've got to pay attention to your scale. So in the scale is 1 unit. But you could just as easily have count by tens. 10, 20, 30, whatever. So be careful about your units. So if it goes up 2 lines, but each one is 10, you haven't gone up 2, you've gone up 20. Right? So do be careful about the scale. Thank you, Hannah. All right, here we go. Let's see. So here we go. I'm going to find a volunteer. It's not here. Diksha, you're my volunteer. Help me out here. What we're going to do